In this video, I am going to discuss first 10 questions from NEET practice set 1. Coming to question number 1, so there is a small correction in the question. P0A greater than P0B. So you make this correction in your book. So read this question. An ideal binary liquid solution with P0A greater than P0B, which relation between chi A, so chi A is called mole fraction of A in liquid phase, and Ya means mole fraction of A in what? Vapor phase is correct. So that means they have given one liquid phase, another one is what? Vapor phase. So in liquid phase for the component A, so you can write the equation Pa is equal to P0 A chi A. For the same component A in vapor phase, you can write the equation like this. Pa is equal to P total into Ya. Ya is mole fraction of component A in vapor phase. Now you can equate these two things because LHS are same. So therefore you will get P0 A chi A equal to P total into Ya. So this is for component A or liquid A. So you call this as equation number 1. Similarly, for liquid B, or you can say component B, you can write same type of equation. So that is P0 B of chi B is equal to P total into YB. So you call that as equation 2. So now you divide equation 1 by 2. You will get P0 A chi A divided by P0 B chi B equal to P total into Ya divided by P total into YB. So P total get cancels out. Finally you will left with chi A divided by chi B into P0 A divided by P0 B, that is equal to Ya by YB. But you read that question, they have given P0 A greater than what? P0 B. Suppose, assume that P0 A value as 2 atm and P0 B value as 1 atm. So what this equation becomes now? So that means chi A by chi B into P0 A we have assumed as 2 atm, P0 B assumed as 1 atm, that is equal to Ya by YB. So what is the significance of this equation? It is very simple. Chi A by chi B ratio, if you multiply with 2, if it is multiplied with the number 2, then only that will be equal to chi A by chi B, sorry, Ya by YB. Is it clear? So when chi A by chi B is multiplied with some number 2, that will be equal to Ya by YB. That means chi A by chi B value is lesser than what? Ya by YB. Is it clear? So this is the final relation between chi A and Ya. So if you observe that, you will get option C. Option C is the correct answer for question number 1. So now coming to question number 2. The solubility of a specific non-volatile salt is 4 gram in 100 gram of water. So what is the meaning of that? That means 100 gram of water 100 gram of water cannot dissolve more than 4 gram of solute, 4 gram of solute at 25 degrees Celsius. So that is the meaning. So 4 gram in 100 gram of water solubility is given means 100 gram of water maximally can dissolve only 4 gram. So beyond that it cannot dissolve. So that is a one key point you have to remember from that question. So one more concept you have to recall here is, suppose if solute is less, that means less amount of solute is dissolved, then its vapor pressure will be more. Vapor pressure of that liquid will be more. So this is the concept you have to remember. So here what are the solutes they have given? One is substance X, another one is Y, another one is Z. You observe. So how much of X is dissolved? So X is 2 gram. So definitely 2 gram will dissolve in 100 gram of water. So that water can dissolve the 2 gram at 25 degree Celsius. So let the vapor pressure of that X, under that condition, let us call that as Px. Now coming to Y. So how much of Y is dissolved? 4 gram of Y is dissolved in 100 gram of water at the same temperature, correct? So that also dissolves, because according to the given condition, its solubility is 4 gram. So that also dissolves. So let us call the vapor pressure of Y as Py. Now coming to Z. So how much of Z is dissolved? So 6 gram of Z is dissolved. But the solubility of the any solute in 100 gram of water is only 4 gram. So therefore, out of 6 gram, only 4 gram will what? Dissolves in that 100 gram. So let us call that vapor pressure after dissolving 4 gram of Z. Even though it is 6 gram is dissolved, only 4 gram actually dissolves. So let us call the vapor pressure of Z as Pz. Now you recall this. Solute less means vapor pressure is more. So since X amount is 2 gram, that is less, its vapor pressure Px is more. Now coming to Y and Z, same amount are dissolved. 4 gram, 4 gram. That's why the vapor pressure of Y and Z will be equal. So therefore, so X greater than Y, that will be equal to what? Z. So this is the correct answer. So option number 4 correct. For second question, option 4 correct. Now coming to question number 3. An ideal solution was found to have a vapor pressure of 80 torr when the mole fraction of a non-volatile. So remember, in your book this question is incomplete. It is given as incomplete question. So please add these two sentences in your book. So non-volatile solute was 0.2. What would be the vapor pressure of pure solvent at the same temperature? So this is the complete question. So there is a typing error in that. So this is a question. So what are the given things? You list out. So P total vapor pressure of the solution is given. So that is 80 torr. You have to find out vapor pressure of pure solvent, that is P01, and Chi2 is given, that is mole fraction of the solute is given, that is 0.2. We know that Chi1 plus Chi2 is equal to 1. So therefore we can easily find out Chi1, that is 1 minus Chi2, that is 1 minus 0.2, that is 0.8. So that is a mole fraction of solvent. So now you can apply the formula. So what is that? Vapor pressure of solution, that is vapor pressure of component 1 in solution is equal to vapor pressure in pure state, vapor pressure of solvent in pure state into mole fraction of component 1 in solution. So P1 is given. P1 is nothing but P total. Okay, P1 is nothing but P total. So P1 is given as 80, that is vapor pressure of solution. Then P01 is given. How much P01? Sorry, P01 we have to calculate. Okay, P01 you have to calculate. Chi1 means 0.8. So vapor pressure of pure solvent will be 80 by 0.8. So this will be 100 torr. So the correct answer is option C. So third question, option C correct. Now coming to question number 4. The vapor pressure of an aqueous solution of sucrose at 373 Kelvin is found to be 750 millimeter of mercury. The molality of the solution at the same temperature. So by reading the question you can identify that the solvent is water. Aqueous means water is the solvent. Then what is the solute here? Sucrose. Solute is sucrose. Okay. So now what are the given information? 373 Kelvin. So 373 Kelvin means in terms of degree Celsius it is 100 degrees Celsius. So 100 degrees Celsius means it is the boiling point of water. It is boiling point of the solvent. So remember at boiling point the vapor pressure of the pure water, that is P01, vapor pressure of pure solvent or pure water. So at boiling point vapor pressure will be always what? 1 atm. Since the one pressure is given in millimeter of mercury, so 1 atm is converted into we have to write in terms of millimeter of mercury. So 1 atm is nothing but 760 millimeter of mercury, that is P01 for solvent it is given. And then what else they have given? Vapor pressure of aqueous solution. So remember for solution vapor pressure of solution is represented as P1 or P total you can write, but in this you take P1. So P1 is given how much? 750 millimeter of mercury. So what we have to find out? We have to find out molality, small m. Small m means molality. And for solvent, remember molecular mass of solvent is m1. So for water, molecular mass is 18 gram per mole. So now what is the formula we have to use here? So it's very simple. That is RLVP, relative lowering of vapor pressure. That is P01 minus P1 by P01 should be equal to Chi2. So after substituting the value of Chi2, finally you will get the formula like this: P01 minus P1 by P01 is equal to W2 by M2 into M1 by W1. So now you multiply both the side by 1000. So if you multiply by 1000, you will get the formula like this: P01 into 1000 on this side, W2 by M2 into 1000 by W1 into M1. So now this factor can be considered as what? Molality. So molality formula W2 by M2 into 1000 by W1. Now we want molality, correct? So molality means symbol small m. So molality small m becomes now, so P01 minus P1 divided by P01 into 1000. So this is 1000 divided by M1. So now you substitute in this formula, you will get molality. So what is P01? P01 is vapor pressure of pure water, that is 760 minus 750 divided by 760 into 1000 by M1 means molality of molecular mass of water. M1 means molecular mass of water, that is 18. So after simplification you will get molality as approximately 0.74 mole per kg. So this is the answer. So option number C correct. For question number 4, option C. Now coming to question number 5. What is the mole fraction of toluene in vapor phase at 30 degrees Celsius above benzene toluene solution? And they have given mole fraction of benzene in the solution phase is 0.400. So remove question mark here. And then P naught B is of course vapor pressure of benzene in pure state. P naught T, vapor pressure of toluene, is given 37 torr. So you remember they have given two components. One is benzene. I will consider that as component 1. Another one is toluene. I will consider that as component 2. Okay, for benzene they have given its vapor pressure in pure state, that is P naught B. I will consider that as P naught 1 because component 1, P naught 1 for benzene, that is 119 torr. So for toluene P naught 2 is given. Instead of P naught T I will take P naught 2. So 37 torr. Then what is given? Mole fraction of benzene in solution phase. So remember, mole fraction in solution phase for benzene is called as Chi1. So that is given how much? 0.4. Obviously you can calculate mole fraction of toluene, that is component 2 in solution phase, that is 1 minus Chi1 using that formula. 1 minus 0.4, you will get 0.6. So after knowing these two things, you can easily find out P total using Raoult's law. So P total means vapor pressure of what? Solution. So what is the formula? P naught 1 Chi1 plus P naught 2 Chi2. Now you substitute all the values. That is 119 into 0.4 plus 37 into 0.6. So you will get 69.8 torr. So this is total vapor pressure of the mixture. Okay, total vapor pressure. But the question is mole fraction of toluene in vapor phase they are asking. So toluene means component 2. So partial vapor pressure of component 2, that is P total, is equal to P total into mole fraction of component 2, that is toluene in vapor phase, that is Y2. This is the formula that is called that is also called as Raoult's law for vapor phase. And here they are asking mole fraction of toluene, that is Y2 in vapor phase. That will be P2 divided by what? P total. So what is P2? P2 is nothing but P naught 2 into Chi2 divided by P total. So substitute that. What is the P naught 2 value? 37 into Chi2 means 0.6 divided by P total is 69.8. So after simplification you will get 0.318. So this is the mole fraction of component 2, that is toluene in vapor phase. So this answer is there in option 4. So therefore question number 5, correct option is fourth option. So now coming to question number 6. The boiling point elevation constant for toluene is. So boiling point elevation constant means Kb value for toluene is given 3.32 Kelvin kg per mole. Normal boiling point of toluene, that means boiling point of the liquid, is given. So that is Tb. So on 110.7 degrees Celsius they have given. Of course we have to convert into Kelvin. So to convert into Kelvin we have to add 273 or exact value 273.15. You can simply add 273 or you can add 273.15. So you will get 383.85 Kelvin. Then of course we need R value, but R value is not given. So ourselves you have to recall 8.314 joule per mole per Kelvin. That is R value. And molar mass of toluene. So toluene formula C7H8. So molecular mass, if you calculate that, 7 times of carbon atomic mass 12, 8 times of hydrogen atomic mass 1. So totally you will get approximately 92.1, 92 actually, 92 gram per mole. 92 gram per mole you will get, but you observe the options, they're all in kilo, so therefore you have to convert into kg. So in kg it will be 0.092 kg per mole. So now what they're asking here, enthalpy of vaporization. Enthalpy of vaporization is represented by symbol delta H VAP. So the enthalpy of vaporization we have to find out. So in NCERT textbook they have given the direct formula to calculate enthalpy of vaporization. So using Kb value, that is Kb is equal to R into Tb square into molar mass divided by enthalpy of vaporization. So now you substitute. So what is the value of Kb? That is 3.32 is equal to R value, of course, 8.314. That is in joules we have to take because options are all in joules. Tb, that is boiling point of the toluene, 3 in terms of Kelvin, 383.85 whole square into M means molecular mass of that liquid, that is toluene, in terms of kg, 0.092, okay, divided by enthalpy of vaporization. So if you cross multiply it, you will get finally enthalpy of vaporization value as 34 kilojoule per mole. So the correct answer is in option B. So therefore for question number 6, option B is the correct answer. Now you read question number 7. So here they have given two components, component A, another one is component B, or you can say two liquids. So for component A, I will treat as component 1. So component B, I will treat that as component 2. For B, what is given? For A, what is given? Vapor pressure in pure state, that is P naught A. P naught A, I will take it as P naught 1, that is 100 millimeter of mercury. For B, I will take it as P naught B, so P naught 2 instead of P naught B. So that is 80 millimeter of mercury. And then they have given 1 mole of volatile component A. So number of moles of component A, that is N1, is given as 1 mole, and number of moles of component B is given as 3 mole. Now you calculate mole fraction of component A, that is Chi1. The formula is N1 by N1 plus N2. So that will be 1 by 1 plus 3, that is 1 by 4. Similarly, you can find out Chi2. So N2 divided by N1 plus N2. So that is 3 divided by 4 you will get. So after knowing that, you can calculate P total. So this is P total means vapor pressure of the mixture. Using Raoult's law you calculate. So what is the Raoult's law formula? That is P01 Chi1 plus P02 Chi2. So if you substitute the values, 100 into 1 by 4 plus, that is 80 into 3 by 4. Finally, the vapor pressure of mixture calculated by Raoult's law will be 31. But you remember the experimental value, that means vapor pressure of the same mixture experimentally observed. They have given how much? It is 90 millimeter of mercury, correct? 90 millimeter of mercury. So compare these two values. So what is the conclusion you can make here is the vapor pressure calculated by the Raoult's law, that is vapor pressure of the mixture, P total of the mixture by Raoult's law, is lesser than the experimental vapor pressure of that mixture. So when vapor pressure of Raoult's law is lesser than what calculated by experiment, that will, so the mixture will shows positive deviation from Raoult's law. So because the experimental value is greater than the value calculated by what Raoult's law, so that's why that mixture shows what positive deviation from Raoult's law. So now you observe the options. First option, it shows positive deviation, that is correct. And of course in positive deviation solution, the forces of attraction, AB forces of attraction, are weaker than AA or what BB, correct. So that's why boiling point will be less. Boiling point has been lowered, that is also correct. And of course force of attractions are smaller, weaker than AA or BB, that is also correct. So therefore all the above statements are correct. So question number 7, option 4 is the correct answer. Now you read question number 8. Calculate the percentage of degree of dissociation. Percentage of degree of dissociation means percentage alpha you have to find out. So they have given electrolyte, that is XY2. So since it is an electrolyte and they have given dissociation, therefore the XY2 electrolyte will dissociate like this. So X2 plus and 2 times of Y minus. Okay, so therefore how many ions you are produced? XY2, 1 mole of XY2 produces how many moles of ions if it undergo 100% dissociation? So definitely 1 mole of X2 plus 2 moles of what? Y minus. So totally number of moles of ions produced will be 3, that is N value will be 3. So now you read that question. Normal molar mass is given. So normal molar mass is given and then molar mass observed by measuring elevation boiling point is given. So 2 molar masses are given. So therefore you can easily find out Van 't Hoff factor. So Van 't Hoff factor will be normal molar mass, normal molecular mass or molar mass divided by abnormal molar mass, abnormal molar mass. So normal is given 164 divided by abnormal is 65.6. So if you simplify this, you will get 2.5. So now using the value of N and then Van 't Hoff factor I value, you can easily find out alpha value. You remember for dissociation process, the Van 't Hoff factor and alpha are related by the formula I is equal to 1 plus N minus 1 into alpha, or after rearranging you will get alpha is equal to I minus 1 by N minus 1. So now you substitute the values. 2.5 minus 1 divided by 3 minus 1, that is 1.5 by 2. So alpha will be 0.75 you will get. But percentage they are asking. So percentage of alpha means you have to multiply this with 100. So you will get 75%. So option number A correct. Question number 8, option A correct. Now you read this question. If the elevation in boiling point of solution of non-volatile, non-electrolyte and non-associating solute in solvent is Y Kelvin and Kb is given. So remember Kb means ebullioscopic constant. Okay, elevation in boiling point of solution. Elevation in boiling point means delta Tb. So delta Tb is given as Y Kelvin and also elevation constant, boiling point elevation constant Kb is given as X. So this is the thing given related to boiling point. Now you read then depression in freezing point of solution of same concentration would be depression in freezing point. Now they are asking about freezing point things. Freezing point. So depression in freezing point means delta TF they are asking, and they have given KF value. So cryoscopic constant KF is given as Z. So boiling point informations are given and they are asking about freezing point. So what is the relation related to boiling point? So elevation in boiling point delta TB is equal to KB into M. M means molality of the solution. So molality will be delta TB by KB. So delta TB is given as Y, KB is given as X. Okay. So we call this as equation number 1. Coming to freezing point things. So freezing point also you can same type of formula. Delta TF is equal to KF into M molality. So now here also you calculate molality. So delta TF divided by what? KF. So delta TF that we have to find out. KF means Z. You call that as equation 2. Now you compare equation 1 and 2. Since LHS are equal, you can equate RHS, that is Y by X will be equal to delta TF by Z. Now they are asking delta TF. So delta TF means you cross multiply, that is Y into Z divided by X. So depression in freezing point will be YZ divided by X. So YZ divided by X means it is option number 4. So question number 9, fourth option is correct. Okay students, now you read question number 10. Freezing point of solution containing 4.8 gram of compound in 60 gram of benzene is 4.48 degrees Celsius. What is the molar mass of the compound? And they have given by the freezing point of 5.5 degree, benzene is 5.5 degrees Celsius. That means, so it is very clear, thus they have given certain compound that we can consider that as solute. So you know that solute is always treated as component 2, and then of course they are dissolving in benzene. So benzene will be component 2, component 1, that is solvent. Okay, so what are the given things? 4.8 gram of compound, that means component 2 mass is given, that is WO2 4.8 gram. 60 gram of benzene, that is mass of component 1, that is WO1 60 gram. Then freezing point of benzene is given, that is freezing point of pure benzene T0F separately given means it is pure benzene 5.5 degrees Celsius. In addition to that, they have given the freezing point of the solution. When compound is dissolved in benzene, it becomes solution. So freezing point of solution is TF, that is 4.48 degrees Celsius. So from this you find out first delta TF. So delta TF formula, freezing point of pure solvent, that is T0F minus freezing point of solution TF. So 5.5 minus 4.48. So you will get 1.02 degrees Celsius. So delta TF is a difference in temperature. So no need to convert into Kelvin. So even Kelvin also same difference you will get. So that's why 1.02 degree Celsius is also okay. So now for benzene is the solvent. KF value is given for benzene, correct? So what is the KF value? That is 5.1 Kelvin per molar is given. So what is the question? What is the molar mass of the compound? That is M2. So molar mass of the compound, that is component 2. So you have to find out, that is M2 you have to find out. So what is the formula? You know that to calculate molar mass of solute when freezing point things are given. So when freezing point is given, so formula M2 is equal to WO2 by WO1 into KF divided by delta TF into 1000. So now you substitute the values. WO2 4.8, WO1 60 gram they have given, and then Kf value is given 5.1, and of course depression in freezing point delta Tf is 1.02 into 1000. So after simplification, the molar mass of the compound will be 400 gram per mole. So the answer is fourth option, 400. So question number 10, option 4 is the correct answer.